Okay, how's it going there, Algebra 2C people? I'd say good morning because it's morning as I'm recording this, but who knows when you're watching this? Could be midnight, you know? Got my morning coffee here, kind of like if I was in the classroom. Not quite during our class time, I guess. I've kind of lost track. So, all right. So you guys, today we're doing lesson 7.4 still, and this is the last installment of 7.4, which is called complex fractions. And unfortunately, it is the tougher of the lessons, and that's why this whole chapter has been rather difficult, or this whole 7.4 process. Which is why we've done one assignment a week with it, where normally we'd be doing more, obviously. So bear with me. This is going to probably be a longer video, but the nice thing about a video is you can stop it and start it at any time. You don't have to watch it in one sitting, but I'm not going to break it up into multiple videos. I'm just going to make one video and do all the examples, and you can watch it as you need to do the assignment. So anyway, basically these questions, you've done everything that's in these questions, but in different problems. So I'm going to kind of explain that, and I'm going to start out as simple as I possibly can. And I'm going to do a total of 5 examples. Now there's 3 up here ready to go. But the first 2 are pretty basic in terms of what do you do. The third one over here gets into the nuts and bolts and the more difficult stuff, as will examples 4 and 5. So the basic idea is we're dealing with a large kind of fractions within a big fraction. So here's your basic idea, and like I said, you can pause this, replay this part, but here's the basic idea. These are basically 3 problems in one. Problem 1. In the big numerator up here, if there's any work to do, anything like add a couple of fractions, subtract a couple of fractions, multiply a couple of fractions, whatever it is, do it. Now this particular problem doesn't have anything to do. There's a 2/9 sitting there. Okay? Problem 2 will be if there's anything in this denominator, do that. Same thing, add, subtract, multiply. If there's anything to do, do it. Once those things are done, the final thing is divide these 2 fractions and get an answer. Now with the first 2 examples that I've chosen, there literally is nothing to do in the numerator denominator. You're going right to the division process. And then with the third example down here, it's going to be more extended. Okay? So here, since there's nothing to do here, nothing to do here, we do the division. Now remember from last week's assignment, actually 2 weeks ago assignment, division in fractions means multiply reciprocal. So we don't do 2/9 divided by 2 over x. We do 2/9 times x over 2. Okay? Multiply is the nicest thing there is because it's just top to top, bottom to bottom, reduce if necessary. Common denominator is not a thing in multiplication, that's addition, subtraction. So if I multiply across the top, I get 2x. Multiply across the bottom, 9 times 2 is 18. And I can reduce right here, the 2/18 reduces. So 2 goes in once, 2 goes in 9 times. We basically have 1x over 9, which most people would write as x over 9. And that's that. So you've kind of done that before in the division process. It's just written a little bit differently. Okay, problem number 2. It's actually about the same difficulty level, but it looks a little different, and I'll explain. But anyway, I think I'll go down here because I don't have a lot of room here. Again, the numerator, there's nothing to do. It's 16 over x plus 6. Like there's no addition to do, there's no subtraction to do. In fact, there's no factoring to do. That can sometimes be an issue. There's just nothing to do here, as is there's nothing to do here. So we're right back to do the division, which means do the multiply reciprocal. So and I'm going to write these times sign as dots. I'm just fixing it. It looks better when they're mixed with x's. Times reciprocal, which will be x plus 6 over 7. Now, multiply top to top, bottom to bottom. Now, before, this one involves distributive property, so before I do that, I'm just going to write it without the distributive. Here's what I mean by that. I'm going to write this top as 16 times x plus 6 over 7 times x plus 6. Kind of see that? Now the reason I wrote that, remember, anytime there's a times and a times, that's where we can do the reducing. Well, the x plus 6's reduce out, and I'm left with just 16 over 7. That fraction does not reduce. You don't have to change it from, like, say, well, the top's bigger, that's improper, that's top heavy. You don't have to change it. You can, but I'm happy leaving it 16 over 7. Okay, now we're getting into the big stuff, the bigger stuff. Example 3, the numerator and denominator have stuff to do. The numerator has 2 fractions to subtract, which means common denominator. The denominator has 2 fractions to add, which means common denominator. So here we go. Now I'm going to try to organize this as best I can. Like in class, I have such a big board space and I organize it, so I'm going to do my best. We're going to do the top up here. Now, the common denominator between 5 and 2 is 10. Remember, if you don't have anything in common, you just times them, so 10. The next question is, or the next issue is to adjust the numerators to balance. Now, how did this 5 become a 10 over here? Remember, this is times 2 makes this a 10. So you do times 2 right there, which makes that an 8. See, 8/10 is 4/5, the unreduced version, but I'm, again, going for common denominator here. How does this 2 become a 10? Times 5. There's how that, so this goes times 5, which is 25. Next, actually do the subtraction with the common denominator, 10. 8 minus 25 is negative 17. And that's as good as that numerator gets. Negative 17/10. Okay, that part's done for a minute. Come back to it later. Now we concentrate on the denominator. So that was actually a problem to do. That's like problem 1. Remember I said sometimes these are 3 problems within 1? There's number 1. Number 2 is taking care of the same thing down here. Now this set of denominators, 2 and 25, nothing, they don't share factors, so we just go 2 times 25 and have to do 50. Okay, so the common denominator will be 50. And I asked the same questions as I did before. How does a 2 turn into a 50? Times 25. So this is going times 25, which will be 25m squared. This one, how's the 25 become a 50? Times 2. 2 times 25 is 50, so this goes times 2, which makes it a 4. Oops. You are ready to do the addition. You have a common denominator of 50. And so you just add the numerators. Now, these numerators aren't like terms. It's 25m squared plus 4. That's exactly what you're going to write. 25m squared plus 4. And that's as good as that gets. Okay, I can't this is almost like something I could factor, but not quite. And that's it. Now, what I'm going to do here is add the original division line here, right here. And you guys, now it's the final question of the three. Like I said, problem 1, get the common denominator, subtract. Problem 2, get the common denominator, add. Problem 3, do the division, which again means multiply reciprocal. So I am going to take negative 17 tenths times 50 over 25m squared plus 4. And I'm going to do that multiplication. So there's kind of a judgment call here. Maybe I should have brought this up earlier. Well, you know what? I'm just going to do this to stay consistent. I'm going to multiply the numbers that I can right here. Which means, so negative 17 times 50, that's negative 850 over, now this I'm going to write as 10 times 25m squared plus 4. Now the reason I'm doing that, again, I didn't do it over here either. I don't want to distribute if there's distributive property until I reduce. Just multiplying this is okay. Now, the reason is this negative 850 and this 10, they can reduce. Negative 850 divided by 10 is negative 85. So like, this 10 goes in once, this goes in negative 85, which means my final answer is going to be negative 85 over 25m squared plus 4. And please note, if that denominator factored to further cause maybe some reducing, I would do it. But that denominator does not factor. So that's as good as it gets. And that's kind of it's not the greatest looking answer, but look at this mess over here that we started with. It's concise, it's one fraction, it's a lot less than it was. So again, it's not called complex fractions because it's easy. It's unfortunately a little bit of a struggle. Okay, I'm going to erase this, and get ready for the next example. I'm probably only going to put one example up because I don't know how much board space it's going to take and I don't want to run out of space. So I'm going to pause a minute. Okay, so here we go, people. Ready for example 4. And this one doesn't look tons and tons different from example 3. Just kind of looking at example 3 on my paper here. But there's more x's involved and less just numbers. So I kind of want to address that common denominator. Now, we're in the same boat in that we do truly have 3 problems to do. We have the numerator, where we have to get a common denominator to subtract. Then we have the denominator, where we have to get a common denominator and add. And then our final thing will be do the division, which again translates do the multiply reciprocal. And I know I'm going to keep saying that, but that way you'll get into your head that, hey, I don't divide fractions. Mr. L has said multiply reciprocal 50 million times. Yeah. So, here we go. Up here, x and 5 are 2 totally different denominators, so multiply them together makes their common. X times 5 is 5x. And then we adjust the numerators. Now, how did this x become 5x? Times 5. That makes the 5x, so you do times 5 up here. And that makes that numerator 5. 5 times 1 is 5. And then this, how did this 5 become 5x? Well, times x. So we do this times x, which in turn becomes x squared. And then lastly, take your common denominator well, maybe lastly. And then do the subtraction of the numerators. 5 minus x squared is exactly that. 5 minus x squared. Now, be careful not to say, oh, I'm going to reduce that. Remember, this goes back a couple weeks now. You can't reduce unless it's attached to multiplication. So this 5 and this x are open to be reduced if possible, because that's a times, but that's subtraction. This 5 and this x squared are off limits. So, unfortunately, that's as good as it gets. Okay, denominator. Now the nice part is the denominator's got the same common denominator as the original numerator problem. 5 and x. So 5x. Okay, same kind of process. How did this 5 become 5x? Times x. So we do this times x. X times 49 is 49x. How did this x become a 5x? Times 5. See? Times 5 makes that. So this is times 5. 5 times 7, 35. So we have our common denominator of 5x. 49x plus 35. You add the numerators. Those aren't like terms. What I said is what you write. 49x squared, x plus 35. And that's as good as that kind of gets, actually. I'm gonna alter that. That numerator, this is the first time this has happened, that numerator can factor just a teeny tiny bit. It has a common factor, a GCF of 7. Okay? So I'm gonna take this problem over to here. That's why I left this. So it's easier to see if I just work straight across. So we're gonna leave this up here. This is 5 minus x squared over 5x. We're going to add the major divided by back in from the original problems because I'm almost ready to do this. That numerator I'm going to call 7. 7 goes into there, so 7x plus 5 all over 5x. See how that's still 49x plus 35? But if there's any factoring to do, you do it because that's where you potentially come across a reducing area. Okay. We are ready to do the division. Hence, multiply reciprocal. So, 5 minus x squared over 5x times 7 times the quantity, 7x plus 5 all over 5x. You saw what I just did right there. I didn't do the reciprocal. Oops, let's fix that. Okay, so times reciprocal would be 5x over 7 times 7x plus 5. There, that looks a little better. Okay, so remember, I'm not doing any distributive properties just yet. Because that's where I see reducing areas. So the numerator I will call 5x times 5 minus x squared. See, not actually multiplying those just yet. In the denominator. Now listen, I'm just trying to see ahead, but you see how there's a 5x here and a 5x up there? A little insight that reduced. So I'm not actually going to multiply anything yet. I'm going to call this 5x times 7 times 7x plus 5. So right there I get to reduce because this is times, so that 5x, that's times, that 5x is out. and there's nothing else. Like this 7's free to reduce with something, but there's no more multiplication left up here, so this is it. 5 minus x squared over 7 times 7x plus 5. So yeah, those take some space. Yeah, I get that, you guys. So I got one more example. Again, I told you this was going to kind of be the long video of the deal, but you know, this is where you can kind of compare, like say, hey, the first two examples match up to the first, or the first example. Give me a little hint here. The first example matches up to questions 1 and 2 for the assignment. And then question like 2/3 lines up a little bit with question 3, and then the remaining examples kind of fit in with the end of the assignment. So you can kind of like look at an example, do a couple problems in the assignment. Look at an example, do them as they appear, and then you can kind of compare. Okay, I'm going to pause again, erase, and one more example. Okay, last example, people. I mean, I'm not trying to scare you at all. I mean, I'm trying to go slowly here, but the final example's probably got the most stuff in it, and it's no worse, hopefully, than anything you'll have to do in the actual assignment. Okay, I mean, I say that, but I know it comes through differently to you. So we're still in the same boat as the last two examples. There are 3 questions within one group. So again, question 1 is going to be get a common denominator up here, subtract. Get a common denominator down here, subtract. They're both subtract this time. And then finally divide. Hence, multiply reciprocal. Okay, so here we go. Now once again, the denominators don't factor or anything, and they're just the common denominator is the 2 just multiplied together. So it's going to be x squared times 2x plus 7. Not the nicest looking thing. Let's just roll with it here, people. So x squared times 2x plus 7. Okay, so now we're going to fix numerators, and I definitely need all this board space this time. So, how did this turn into this? The difference is times x squared. Think about if I just went, see, that looks like that now. So this needs to be times x squared. X squared times 4, that's 4x squared. Okay, how did this denominator become this? Times 2x plus 7. See, that looks like that now. So this needs to be times 2x plus 7. And I know this can be confusing, but I do distribute here because I have to subtract, and I need to see like terms if they even exist. So 16 times that times 2 is 32x. And then 16 times that, let's see, 112? I better check that. 16 times 7, 112. All right, haven't lost it totally. Yeah. So we're gonna move this along in a minute. We're gonna move this along right now. We'll move this over to the other board. We're gonna actually do what's known as the subtraction here. Now let's be super careful here. This will stay x squared times 2x plus 7 for now. And this numerator has no like terms. X squared, x, and numbers. But you gotta be careful. You're subtracting the second. So, it's like the like terms that aren't there, but it's 4x squared minus nothing in terms of x squared. So the 4x squared is there. But you gotta see this is minus 32x. Minus 112. So that's kind of a messy. Now, it appears to me, I told you I'm saving the best for last, that this numerator is going to factor in some way. And once all is said and done, you want it as factored as possible, because that's where you'll eventually notice like terms to, or not like terms, but common things to reduce. So on first sight, and I'm going to do that because I'm going to run out of space, I think. I'm going to do a little bit of work up here. I'm pretty certain that there's a GCF of 4. I know that obviously 4 goes into 4, and I know that 4 goes into 32, but 112. 4 goes into that too. So I'm going to write this. I'm going to just take the GCF out right up here. So 4 comes out, leaving me x squared minus 4 goes in 8 times. And I just found out here 4 goes in 28 times. Okay? And the reason I did that up there is because I was thinking maybe this would factor more, but I don't think it does. It does not. So I thought it might, thought it would work out for us. So right here, we're just going to write 4 quantity x squared minus 8x minus 28. And that's as good as that gets. I mean, I thought this would factor more. It certainly had a look that it might, but it didn't. Okay, so that was kind of a doozy. That's one problem all in all of itself, but here we are. We'll come back to that. Let's go down here. Let's hope that this one's not as messy. Now this one, the common denominator work should be a little less of a pain because 4 and x squared are just going to work together as 4x squared. Okay, back to like make the changes. Now how does that work? Well, the way that this 4 became a 4x squared is times x squared, right? X squared times 4 is 4x squared, so this gets times x squared. X squared times 1 is just x squared. This fraction, this x squared, needs to become 4x squared. That happens by doing times 4. So that's what I do to the numerator. Times 4. Now, remember, I do distribute here so I can work with like terms in a few minutes. So that's going to be 8x. And that's going to be 28. Moving along, I am ready to do the subtraction. Okay, common denominator of 4x squared, subtract the numerators. Now once again, these are not like terms at all. So there is just the x squared from here. It's minus both of these, so it's minus 8x minus 28. Now, I'm just going to move this over here so that it's in line with the other one. But there's the big division left to do. And listen, I'm feeling pretty good about this one. And you guys, I want you to know something. Don't think of this as me being unprepared. I didn't do this example before I started videotaping, because what's important for you to see is like maybe there's a stumble and I have to stop and back up and do something. But there's something very promising about this problem. You see this top mess of a fraction has x squared minus 8x minus 28 in it. This bottom one has it too. That's making me feel like, hey, there might be a good reduce here. Now, the next thing to do is to write it as multiply reciprocal. I've got everything done as much as I can do. It's time to write it as multiply reciprocal. So for quantity x squared minus 8x minus 28 all over x squared times 2x plus 7, I hope I got enough room here, times, flip, 4x squared